DevOps is not really just about technology, it's also about the teams and the people that make up the technology.
Something so different. Something so different.
I was hired as a DevOps guy, which you'll learn later is a strange title, because DevOps is not really a title or a set of skills or anything. It's more about the stuff Calvin was talking about culture and automation and monitoring and sharing knowledge between different people in your organization. I used to be a system administrator for a very long time, and basically fell into DevOps by trying to make my job easier. To me, being able to be sure about what my servers were doing and how they were configured, the only way to do that was through automation. And this really smart guy named Mark Burgess, he's like this brilliant physicist guy. In the 90s, he wrote this piece of software, and he published this paper called Computer Immunology. And what computer immunology means is, you know how like humans and communities and other systems like this have ways of maintaining stasis. Like every time you sneeze, you don't go to the doctor and figure out what's going on with you, or go get a blood test every time you stub your toe. Your body's immune system is capable of maintaining this stasis of health. And one way to think about this is that despite the fact that all of us are quite old, none of the cells in our body are old at all. They're constantly dying and being regenerated, and server systems and computer systems are tragically fragile. Like if a single thing in a configuration file is wrong, it can bring your system crashing down. And there's really no stasis for software systems. And Mark Burgess wrote this paper about trying to change it. And the way that he approached this problem was with automating the configuration process of your systems. And the way it works is, as the system administrator or software developer, what the state of your box is, like what the state of your machine is supposed to be when you have working software. You know how to get there. You've configured Apache or whatever, and you've installed the right packages, and you've configured your database and all that stuff. And that knowledge is stored on the computer, and the configuration files spread all over the place, and it's also stored in your head. What configuration management automation software does is allows you to put that stuff into files that you then execute like code against your servers. So some of the configuration management systems that you may have heard of are called like Puppet and Chef and CF Engine, and Ansible is one that's quite new. But not doing this by hand allows you to maintain really complex infrastructures without having to constantly tend to every single failure that happens, because you've stored this configuration in your configuration management system and then applied it to a bunch of servers. Some of the beneficial side effects of this are that you can then use like normal, good, or what I would call normal and good software development practices against your infrastructure. So you can do stuff like continuous integration, and you can write automated tests for this, and you can use version control, and you can do peer reviews, because you can see at a glance what your servers are supposed to look like. So having all of your configuration stored in a configuration management system also makes auditing a lot easier. So you can use automated tests and then audit the state of your systems to ensure that they are what they're supposed to be. And you can do this at a great scale because you don't need to touch anything. You have your configuration management, you have your continuous integration server doing this stuff for you. All it requires you to do is the front side investment of writing some tests. It's also like having consistent state is pretty pinnacle when you're trying to diagnose what's gone wrong in an application or what's changed. Knowing that your configurations are going to be the same everywhere comes in really handy for diagnosing problems. You can pretty much rule out the configuration as being the cause of the problem if you know that nothing has changed there. Another side effect benefit of this is the ability to like quickly and reliably spin up correct environments for doing other things. So if you need a QA environment, traditionally what you would do is you would go and talk to whoever the ops people are, whoever the ops guy is, or girl at your organization and tell them, okay, I need servers provisioned, and then they would sit there and they would go and type things, and they would configure your environments. And having your infrastructure as code allows you to sort of build a more self-service organization where if you need another environment to do some testing in or to do some performance reviews or whatever, you can then ask your continuous integration tool to tell your configuration management to spin up another instance of whatever your stack looks like. This also lowers the cost of the brain and pain cost of scaling in a huge way. Because if you think about it, if you have 4 database servers and all of a sudden you need another one, the cost of spinning one up if your infrastructure is stored as code is almost nothing because you've already done it and you just need to add it to the pool. So you apply your database role to the server and you're done, and add it to the pool. So I guess the way to remember, or the way to kind of ask yourself what you're doing is a good analogy is that you should treat your servers and your infrastructure like livestock, not like pets. So like if your cat gets sick or your dog gets sick, then you take them to the vet and you care for them and you pay attention to them and you ensure that they have all the things that they need. And this is not how you should be treating your servers. You should treat your servers like livestock. If your horse is very old and sick, you take it out the back and shoot it, and that's how you should treat your servers. If something goes wrong, you should have things automated to the point where the time and brain investment of diagnosing what's actually wrong is too high, and you should just tear that box down and reapply your database role and see what's going on. You shouldn't waste time diagnosing issues. You should just take it out the back and shoot it. And that's kind of all I have. For me, if I were listening to this talk, for me the thing that I would be thinking is how do I get good at this? And it's not just about learning these tools like Puppet and Chef and Ansible, although that's a big component of it. And those tools have great tutorials and actually we're gonna have a workshop a little bit later about how to use Chef, and we're gonna go into great detail about how this stuff works. And you guys are gonna need to try it. But the resources are out there to learn the tools, and there's some really good content that comes from conferences like this. If you look at previous DevOps Days, DevOps Days videos, there's really good talks that you can learn a lot from, and that's pretty much all I got. Does anyone have any questions?
wanted to know more about like how people can get started with DevOps. I'm not sure if you really answered that question.
Yeah, I would start pursuing learning the tooling first. And there's a guy named John Willis who has a blog called DevOps Anywhere or DevOps Everywhere, I believe. And he's really, really good. And learning the tooling is pretty important. And I would start with the tutorial this afternoon. Then we'll go into more detail about how what other resources you can use to learn. That's all I got.
How is it easy to move from non-DevOps culture to DevOps culture? Have you had experience in migrating with the
It's quite difficult.
Could you repeat the question?
Oh yeah, sorry. The question was, how difficult is it to transform an organization that is more traditionally structured to an organization that embraces DevOps? And it's very difficult. The size of the organization plays a huge part, and the kind of the developers themselves, the people in the organization, are obviously the biggest, the most difficult parts to getting this culture to fly. Because all of a sudden, people whose responsibilities were just writing code and hopefully writing tests and running it is now like, how do I deploy this code? How do I automate the deployment of this code? How do I make it work in production versus in testing? And what are the configuration settings? And they have to learn a whole breadth of skills and knowledge that they didn't have previously. So if the people in your organization are motivated and interested in learning this stuff, then the transformation honestly happens kind of naturally. In big organizations, generally what we do, ThoughtWorks does this stuff, and they call it a DevOps transformation. The way that they start is generally you take one team, you take a high-performing team. Hey guys, what are the worst things about deploying software for you guys? And then you start automating those things, and you start sharing the skills between the teams or between the team members about how everything works. And then you kind of see if those ideas pollinate to other teams in the organization. It's difficult. It takes a long time, and since it's mostly about people and culture, it's really about what people want. That's my shit on that. Anybody else?
When it comes to legacy, how does DevOps make it, or how does it apply with legacy scenarios? We have some things that you can't be automated, or something that you have at the cost of maybe complexity of automation is such that some things are not possible to automate. Maybe that's something. How do you do with legacy? Because you get to it when you're starting from scratch, and you have to work with a system that doesn't have to work.
So the question was how do you get automation around, or I think the question was, how do you get automation around legacy systems? Because it's more difficult than when you're trying to automate a system that you're just starting from scratch. And the answer to that is when you're looking at this legacy system, you just look for the smallest parts. You look for the smallest moving parts in the system, and you start to automate those first. And when you start tearing apart like legacy systems or just any system in general, and you start teasing out parts of it, you'll often see that the way that the application was architected, if it doesn't lend itself to automation, then it's probably not ideal. And you should start by re-architecting the smallest pieces of the application that you can to allow you to automate them. Because the cost of the cost of doing that may seem high initially, but the cost of manually maintaining a service or an application or a system of applications is incredibly high over time, and it requires domain knowledge, like experts in this one application, and then that guy quits or gets hit by a bus, and then like you're in trouble. So having yeah, in my experience, I think you should like teasing out small parts of legacy applications into self-contained applications. Like if you're talking about web applications, or I'm thinking web applications specifically, but just teasing out parts of them and then automating them as you go along, you will often discover that that you can re-architect it in a way better.